this successful end. So our topic today will include certain subjects: role and function of network components, characteristics of network topology architectures, and comparing physical interfaces with the cabling types, as well as interface, how you can identify interface and cable issues, which includes collision, error, mismatch, duplex, and speed. Of course, at the end of our first subject will be comparing TCP and UDP protocols. Let's start. So, networking today. As you may know, there is a various network today, and those networks could be complicated, could be easy created networks, but we should know what those networks are and how they created. So, in the network environment, there is a host and server role. How we can explain that? So here on the presentation which I prepare for you, we have a client and we have a server. So what is a client? Or we call it also end device or host. So client could be any computer which is behind the client is the user. Host could be any computer, could be server or a client. So end device is a client. So servers are computers here, computers which are providing services. So for computers which are giving us services, those we call it server. For example, email server, web server, file server, DNS server, and Active Directory servers. Those are servers. Client, from other hand, is computers which are consuming those services. That's why we call it client. Peer-to-peer role. Still we are in the position of the network component. Peer-to-peer role is possible to have a device be a client and the server in peer-to-peer communication. Why? Because peer-to-peer communication is not centralized, is not secure, because every single computer is taking care about its own security and about its own administration. Low cost, of course, because we are not creating a complex network, and slow performance because it's one network, one-to-one, so node to node, host or client to server. So that's why these networks are not preferred really in large businesses. So these networks you can establish at home or a very small offices, which possibly could this network be beneficial. End device. We talk about again that end device is a computer which behind that computer is the user. So as you can see here, we have end device in this network and we have end devices in that network. So end device is the computer behind. After it or behind that computer is the user. So as you can see here, we have a LAN, we have another LAN, and between LAN we have internet. So this is your internet or the network itself. This internetwork allows all end devices to communicate to each other. So if one end device sends the message to this end device, it will go through the internetwork. So in this internetwork, if we go back here, in this internetwork, we have many devices. We call them network devices. Those network devices we're going to talk a little bit more further. we're going to point those network devices that they are LAN switches, routers, multi-layer switches, and wireless router, as well as firewall appliances. So I would like to point here that we're going to talk about LAN switches, or just a switch, and routers, because those are core intermediary devices in any network. Of course, there is a wireless routers, but the principle for all those devices are the same. Multi-layer switch is not more than a switch with router capabilities. Here we call it layer 3 switch. Okay? Firewall appliances is a firewall device which is dedicated to be a firewall. What we know about the firewall, that it's filtering the incoming and outgoing traffic. Always, guys, remember that. Firewall or any securing device good securing device must filter by any measurement incoming and outgoing traffic. So intermediary devices, router and switches and the others. So example we see here in the picture, what they do. They manage a data, they redistribute a data, regenerate and retransmit the data signal, maintain the information about what paths exist in the network. We're going to talk about that. This is the key function of the router. What paths are existing in the network and which is the best path for the router to forward the package. And notify the other devices of error or communication failures. Now, network media. As you know, computers, network devices, they're connected somehow, right? Those devices, they need the communication media. Media in this case is cables or wireless, fiber optics, right? Also, we could stand with those three for now. So cables, which is wired, copper cables, wireless, fiber optics, and what those cables are made of. So media types, so metal wires within a cable, so use electrical pulses. So those are cables here. We're going to talk about more in details later. Glass and fiber optics cables are here, and wireless transmission. Now, those wired cables use electrical impulses. What's the core of these cables? It's metal. It's called copper. So it's a conductor. So it's very good conductor. So it's provided electrical impulses. So this cable is actually carrying out data. And all cables which are connecting our computer into the network, it's made by copper core. There is many different cables which you can create from the copper cables. We're going to talk about that later. So fiber optics, just few words, keywords, or few important things that I can say about the fiber optics. That fiber optic is a high transmissible cable. It's high bandwidth. It's very efficient cable. Why? Because the core of the fiber optics is made from glass. And what's the carrier of the signal? It's a light pulse. Wireless transmission is made by wireless network or radio waves. Radio waves, you know, they have frequency some frequency they are better transmitting than another frequency, but that's why we have different wireless standards. We're going to talk about those standards later as well. So, network representation and topologies. As you know, network represents itself in the world. There are different networks and they must somehow connect to each other, as well as certain organization at the beginning, when the internet was created, they decide to do certain rules and topologies how the network must be constructed. Again, here, just to remind you, okay, here, the network representation. We have end devices in the network representation. We have intermediary devices, we already talked about it, and we have a network media. So, end devices, they are formed by desktops, laptops, printers, iPhones, IP phones, wireless tablets, telepresence, and endpoint. But the most important thing, guys, as I already explained, end device is everything which stays behind that end device is the user. So your phone, if you connect your phone to the wireless, your phone became an end device. But if you provide using the hotspot from your mobile phone to another person, then your phone became an intermediary device. So intermediary device here is a wireless router, LAN switch, router, multi-layer switch, as we already talked about. It's a layer 3 switch which has router capabilities, and firewall appliances. Here as well, network media. It's created by wireless transmission, LAN media, which is actually our copper cable or fiber optics cable, but mostly copper cable, and WAN media. WAN media is created by fiber optics or serial cables. We will talk about that as well. So what is important, guys, to know in terms we are using in the networking? Network interface card. Basically every device, if the device needs to be connected within the network, it needs network interface card. Without it, the device cannot be present in the network. Then also, physical port and interface. Physical port is exactly the physical place where the cable it gets into the device. The interface is the logical abbreviation of that physical port. Logical. For example, LAN switch has 6 ports, right? Or more. Those are physical ports, but those ports has a logical abbreviation, or we call it interfaces. S1, S2, S3, S4. So those are interfaces. On the logical map, those interfaces are there. Okay. Often the terms port and interface are used interchangeably. Topology diagrams, guys. So here we have 2 types of diagrams and 2 types of topology. Physical topology, as you can see here, it's just the devices, but here we're talking about representation of those devices on the network map. To know exactly those devices, how they standing in the network, we need a topology. So any network administrator who is running a network department, it needs the topology, physical and logical topology, just to know its own network. And it's better for troubleshooting. That's every single administrator, every single technician needs to know where is located any device and what's the logical information about that device, IP addresses, port numbers, and etc. So here we have two parts, two topologies. One is a physical one from the left side, and from the right side is the logical one. So physical LAN, physical topology. What is interesting for physical topology is that it's basically give you the information of the location and physical part of the servers. As you know, servers or any network equipment in large companies, they are placed in specific IT rooms. Those IT rooms has IT racks. IT racks, they have many shelves, and all network equipment, servers, they are rack mounted, so you can mount them in those shelves, and those shelves can be hundreds, thousands. So you should know the exact location of your device. As you can see here, which is really nice, and you can really quickly navigate and troubleshoot your network environment just by locate your network device just by looking on that topology. So here is your network structure. The same network structure is valid for both. But what we have here, we have a server room. So we have a physical location of all devices in this network. Then after, you have a rack 2, shelf 1, and the description of this machine. And this machine description is web server, right? Then you have an email server on the rack 2 and shelf 2. Of course, this is not just a document. On the machine itself, you must have also tags. Tags are those little stickers or marks which are exactly the same as on the map. On the right side, you have a logical topology. Logical topology is completely opposite. It gives you the logical description of all network. First, every computer, so every server, every network equipment has IP address and port interface where it's connected to the network. So here we have this network, right? In this network, which is the same on the left side, as you can see, the map doesn't change. We keep it the purpose, the description of the server, but now we know which interface, it's a physical port, is connected to the network and its logical abbreviation, which is F01. That's the tag, that's the name, that's the mark of the interface of this web server. And of course, the network address of entire network. Of course, you can also put every single IP address of every single interface, but map will be really detailed, and sometimes it's not necessary. It's going to be too complicated to read that map. And what is most important, the core router, which is forming this network and its default gateway, has also all interfaces visible, how they connected to the internal network or to the intranet. Now, common types of networks. Networks has many sizes. We have networks at home. We have networks at small businesses. We have networks in very large corporations. But how we call them and what it means in terms of network. So, small home or any one of us which is placing at home, we're having a small network, and we call it small network. Then we have a little bit larger network, but still small as a company, and we call it SOHO. Small office, home office. Then we are moving forward, having a medium or large companies, which are small building or medium-sized building or really big building, skyscraper. And then we have a worldwide, the entire world of all communication channels and all computers, right? So small office connect a few computers. Enables a computer within a home or remote office to connect the corporate network. The medium to large networks, many locations with hundreds or thousands of interconnected computers. So for example, we're having a headquarters in Montreal, then we're having another headquarters in Toronto, and another one in Vancouver. All these three buildings are communicating between each other with one big, large corporate network. And there is thousands computer inside that building. So that's called medium and large network size. LANs and WANs. Now, how is the path of connecting end device to the network and how the data is going from one device to another device, for source to the destination? It's always a two parties, source and destination, right? So, first, we're having a computer connecting to an internal network called LAN, right? Then we having a LAN connected to a WAN, which is actually our internet. There is a little bit a more small variation inside before we get into the WAN, but we're not going to discuss today. We're going to discuss that in with different subjects. So, network infrastructure vary greatly in terms of size of the area is covered, number of users connected, number and types of services available, and area of responsibility. So LAN, local area network, is basically your building. So the geographical location for this is limited to building, small building, big building, large building, but still a building. The LAN, local area network. WAN is a wide area network. It's if you are trying to connect, for example, Toronto head office with the Montreal or Vancouver head office buildings. So it's a city to city, country to country, or continent to continent. That is your WAN connection. So what does do LAN? LAN interconnects end devices. So every single computer inside the LAN, every single server, every single switch, every single router, it connects all end users, all computers together. So administered by a single organization or individual. Of course, if you're running an Active Directory in that company, all computers will be authorized, administered, secure by one server, one domain controller. But this is a different subject. We're not going to talk about that. So provide a high-speed bandwidth to internal devices. Because of the high-speed bandwidth of internal devices, your LAN network is very fast. WAN interconnects LANs together, or before WAN there is another types of network, which are MAN, which is Metropolitan Area Network, and exactly those networks are connecting LANs together. But MAN is the part of WAN, which means Wide Area Network. That's why they directly here is telling us that WAN is interconnects LAN over the wide geographical area. But you have to keep in mind, inside the WAN we're having a MAN, Metropolitan Area Network. So Metropolitan Area Network connects LANs together, local area networks together. One area network connects cities, countries, and continents. Internet at the end, right? So the big internet, the invisible internet. So internet is a worldwide collection of interconnected LANs and WANs. Basically, it's the entire world. So LANs are connected to each other using WANs. WANs may use copper, wires, fiber optic cables, wireless transmission. It doesn't matter which cable is depends on the owner of the company or a person who wants to create that network. But those are variations. Wires, fiber optics, cables, and wireless transmission. So the internet, because it's growing every day, every minute, every second, is not owned by any individual. It's not owned by any private company, but is regulated by non-profit public organization. So those organizations are IETF, ICANN, and IAB. So those different organizations are responsible for the different regions. Some of them are North America, some of them are responsible for the Europe, and some of them for Australia, New Zealand, and etc. But those organizations, they are responsible for ruling and helping maintain the structure of the internet. Now, internet connections. Home and small office internet connection. So we're having here a small and home office. First, how we can create a small and home office. What you have at home, you have a modem, right? You have an ISP provider, internet service provider, which provides you an internet, right? So you are accepting that internet through the modem. Then from the modem, you are connecting your modem with the cable to your wireless router, and from wireless router, you redistributing the signal inside your home. So cable, we should know. What are the types of getting the internet to your home or be connected to the network? So cable, high bandwidth, always on, internet offered by cable television services providers. It could be any cable provider which is licensed to operate in your country. DSL is a different type of connection. It's a high bandwidth, again always on, internet connection that runs over a telephone line. So you must have a telephone line. So it's provided by telecommunication provider. So telephone line. And over this telephone line, you're going to receive an internet or connection to the network, worldwide network. Cellular, use a cell phone network to connect to the internet, right? So it's your mobile phones, guys. So ladies and gentlemen, here we are using daily those mobile phones and we are using daily this cellular network. Satellite, which we not use that often, that network. Maybe some of us never used it before. Why? Because satellite network is given only in rare occasions when we don't have a network around it. For example, inhabited area like a desert, like Amazonian forest. Somewhere there is no technological advancement and we cannot use our telecommunication channels. And at the end, dial-up telephone is the legacy already. There is not in use anymore, but at the beginning when the internet was provided, we use a telephone line and dial-up connection. Business. This, what we talked was about the home office, but business is using a little bit different type of connection. Dedicated lease line, very expensive. Why? Because it's dedicated. exactly for that company. So basically it's they build it point-to-point connection, and they put between them a dedicated cable. It could be a fiber optic or any other transmission cable. And this cable is dedicated for this company. And as well as the speed is guaranteed. That's why this line is very, very much expensive. Ethernet 1. This extends your current LAN access technology into a WAN, wide area network. DSL. Business DSL is available in various formats, including symmetric digital subscriber line. DSL is the business DSL line. Is available in various formats, including symmetric digital subscriber line, SDSL, and at the end again is a satellite. Actually, the satellite is mostly used by companies because they can afford it, because directly the signal of the internet is coming from the satellite, so they need a dish, a special satellite dish, which is receiving the internet signal from the satellite. Reliable networks. What we need to have in our network in order to provide the security, the resilience, we need the fault tolerance. What does it mean, fault tolerance, guys? It means that if certain device is broken or certain path is off, still your data must be delivered at the destination. How it happens? It happens, there is many ways how the data can travel. So fault tolerant network limits the impact of a failure by limiting the number of affected devices. Multiple paths are required of fault tolerance. For example, as you can see, PC1. So one of the computer wants to send the message to another computer. So it will go through the switch, then it will go to the first router. Then, after that, it has choice. It needs to go to one router on the left or one router on the right. If the router on the left is not responsive, or there is no response, or the path is broken, so the router will choose another path to deliver the data. But the most important thing is we must have the multiple path to integrate the fault tolerance. Reliable network provides redundancy by implementing a packet switch network. So what does it mean that? So packet switching splits the traffic into the packets that are routed over the network and take different paths in event of breaking line or breaking a device itself. Scalability. Scalability is another feature that we must have in our network. Why? Imagine that you're a company and you are preparing your devices. So you are ordered 1,000 computers, you order all network equipment, everything. But in the future, after 1 or 2 years, you see that your clients triple. It means 3 times more. Then you have choices. You have to get more equipment, hire more agents to serve your new 3 times more clients. But if you not in advance, whenever you create your network, if you not put there scalability, you're not going to be able to expand your network. That's why it's called scalability. So anytime you can extend and expanding your network. So scalable network can expand quickly. That's the key word. Quickly and easily to support new users and application without impacting the performance and services of the existing users. So as you can see here on the picture, we're having a network which recently has been added to an existing network. We just connected to the router. Network security as well. So we must implement our network security by adding firewalls, the physical security of the network devices. As you know, every network equipment or any equipment is behind the very secure doors with the physical access, with the key card. Then after you should have keys of the racks to access the actual devices, and you must have also a logical security for providing security from the hackers, from the intrusion from outside. Such security are firewall appliances. We're going to talk a little bit about topologies. So topology of a network is arrangement and relationship of the network devices and interconnection between them. So, what kind? Again, topology we already know is the physical and logical topology. Physical shows a physical connection, where they're located, which rack, which room, which shelf. Logical topology identifies the virtual connection between devices using device interfaces and their IP addresses. Or you can remember the schema which we saw early in the slides, which give you the interfaces, the logical abbreviation of the interface. For example, for the router was FA0, and the IP address of the entire network. There are three common physical WAN topologies. Point-to-point, that's the smallest and most common WAN topology, consists a permanent link between two endpoints. I gave you the example before, when two network connection, when two sites are connected to each other with a dedicated lease line, so they are using point-to-point connection. Hub and spoke, similar to a star topology, where central site interconnects branch sites through the point-to-point link. And mesh WAN technology provides high availability but requires every end system to be connected to every other end system. So basically here we have a really good resilience and redundancy, because every system is connected to each other, and if one falls, the another could provide the connection. So what we have else, it's a point-to-point WAN technology. It's a physical point-to-point technology directly connected to nodes, as we already talked about it. The nodes may not share the media with other hosts. So it means directly point one device to another point to another device. The nodes may not share the media with other hosts, because all frames on the media can only travel to or from two nodes. Point-to-point WAN protocols can be very simple. LAN topologies. End devices on the LANs are typically interconnected using a star or extended star topology. So most efficient and most widely used topologies now, these days, is a star topology and extended star. Here, those two. Bus topology and ring topology, they are legacy topology, but still we talk about them because might be somewhere in the world they might still exist those topology. For those countries who has history in early days of the internet. So bus topology, all ends system chain together and terminate at each end. But there is a gap here. If we break the line or we break the cable, it means the entire network go down. Here it's valid the same. If we break the cable, the entire network goes down. As well, imagine that networks not go down. This network, it's a half duplex. It means first you're sending, the channel is busy. Then, if you want to receive, you must wait until the channel gets free. Then you receive the data. You cannot receive and send the data at the same time. So half in that matters, because I already said full duplex, we're going to talk about the important stuff, which will basically on your exams. half duplex and full duplex. What's the difference? So half duplex allows one device to send or receive at the time of the shared medium. One device send or receive. Used on WLAN, wide local area networks, and legacy bus topologies with internet hubs. Full duplex allows both devices, means sending, receiving, both devices to simultaneously transmit and receive on a shared medium. Ethernet switches operate in full duplex mode. They are sending, they are receiving the data. That means full duplex. That is for this section, which I already said about at the beginning. Now, the next subject, we will talk about comparing physical interfaces cabling types, interface cable issues, and comparing TCP, IP, and UDP. So be with me, bear with me, and we'll see shortly. Hello again. So next topic in our today's course is characteristics of physical interfaces and cabling types, which are part of the physical layer, as well as interfaces and cable issues, collision error mismatch duplex and or speed, and comparing the TCP and UDP protocols. Physical layer, which stands on the physical of our devices. Physical layer characteristics. So physical layer in our OSI model, it stands at the beginning. It's the first layer of 7 layers OSI model. What is there? Basically there is your cabling, your network cards which are preparing the data to be transmitted through the medium. And medium is actually our cables. So physical layer standards address 3 functional areas: physical components, encoding, and signaling. The physical components are the hardware devices, media, and other connectors that transmit the signal that represents the bits. Bits is the form of the information. It's zeros and ones, right? It's a binary language, which computers, by the way, they are communicated with the binary language. Now, bandwidth. These terms you must know very well. What does mean bandwidth? Bandwidth is the capacity at which a medium can carry the data. The bigger is the capacity, the more data you can transmit over the medium. The digital bandwidth measures amount of data they can flow from one place to another at certain time of period. So we have unit of the bandwidth, bits per second, BPS. Then we have a kilobits per second, kbps, and mbps, which is megabits per second, and gbps, which is gigabits per second. Bandwidth, kilobits per second, which we have in the abbreviation kbps, which is 1000 bits per second. 1 megabits per second, it forms a 1 million bits per second. Bandwidth, kilobits per second, which is 1000 bits per second, megabits per second, which is a 1 million bits per second. Bandwidth terminology. So we should know, because those terminology will be in our exams. So I would like you to prepare it. So those 3 terminology you must learn by heart. Latency is amount of time, includes delay. Data travel from one point to another, including the returning back. Throughput is the measure of the transfer of bits across the media over a given time of period, and good put is the measure of usable data transfer over a given time of period. Now, because we talk about the physical layer, and on the physical layer it stays the network and the cable itself, the media through which we are sending our data, and data is traveled across the globe. So, characteristic of the copper cabling. So, copper cabling is the most common types of cabling which we use to create our network. Inside the local area network, we use completely all and only a copper cabling, but if we talk about the large distances, there is a certain limitation of the copper cabling. So, attenuation. More is the distance of the cable, more the signal, electrical signal, is weaker. So that's why in the very large distances, in one wide area network, we're not using a copper cabling. We're using a fiber optics. Also, the electrical signal is susceptible to the interfaces from two sources, which can distort or corrupt the data signal. One is EMI, which is electromagnetic interference, and RFI, which is radio frequency interference. Those cables are affected by that, and the signal can be distorted. Mitigation. Mitigation, strict adherence to the cable length limits will mitigate attenuation. Some kind of copper cabling mitigate EMI and RFI using metallic shielding. So some copper cabling, they have a lot of shields inside to prevent this distortion. For example, copper cable has a rubber, then I have a plastic, very thick plastic isolation, and they have a set specific fans which is working as a Faraday cage, which not allow the electrical and electromagnetic signal to distort the signal inside the cable. Type of copper cabling. We have a certain types as unshielded twisted pair types in this section. Then we have a shielded twisted pair types, and we have a coaxial cable, right? In unshielded twisted pair types, UTP for short, we don't have a shielding. So those cables are not good to use if you know or if you have a really big distortion sources like electromagnetic fields or radio frequency fields, because they don't have shielding. The shielded twisted pairs, they have a shielding. As you can see, the shields are on each cable, and of the whole set of twisted pair cables as well, we have shields. And coaxial cable is the most shielded cable. So we have as I already said, we have a core, the copper core here. Then we have a thick plastic insulation, and we have a metal fence, which is preventing for the electromagnetic distortion to get in and distort the signal. Unshielded twisted pair, it's a 8 separated twisted pair cables which are twisted by 2. So it means we're having 4 groups of cable twisted by 2, and that cable is using to form our local area network. At the end of the cable, we are terminating cable with RG45. RG45 is the connector which is getting into the cable, and then we're using that connector to connect the cable into the network. Shielded twisted pair, as I already mentioned, it has a braided flow. Shield provides EMI and RFI protection, or we call it fence or Faraday cage, and the same principle. We have an internal foil shielded to each pair, which also provide that protection. And at the end, we have color-coded plastic insulation, electrical isolate the wire from each other. And at the end, the cable has an outer jacket, provide the copper wire from physical damage. Coaxial cable. Coaxial cable consists of the following. So outer jacket, this is prevent from physical damage. Always we need an outer jacket or rubber to prevent a physical damage. A woven, bright and metallic foil acts as a second wire and circuit as a shield for the inner conductors. Then, third one, a layer of flexible plastic insulation, and the fourth is actually our copper core. How we connect it to the devices, our coaxial cable is using connectors. We're having a BNC, N-type and F-type connectors. Most of them you probably already know, but for example these cables, so there are different types of connectors to connect the copper cable or coaxial cable. So commonly used in the following situation: wireless installation, attach antennas to wireless devices, or cable internet installation, customers premises wiring. UDP cabling. So UDP cabling has 4 pairs, and each pair has color, right? So colors are orange, white orange, blue, white blue, green, white green, and brown, white brown. Depends how you are lining up those cables, you can create 2 different types of cables. Let's talk about it. So, making a different standard type of cables, you're creating different type of cables. Those type of cables, we call it straightforward cables and crossover cables. UDP cables has 4 pairs by 2 cables, and they are divided by color: orange, white, orange, blue, white, blue, green, white, green, and brown and white, brown. By variation of those cables, you can create 2 types of cables, which we're going to talk about a little bit later. So standards for UDP are established by the organization, and there is standards for those cables: cable types, cable lengths, connectors, cable termination, and testing methods. So every cable, UDP cable, has a category. The higher is category, the more beneficial is the cable. So less category is less beneficial is the cable. What's the benefits of the cable? Is the speed which is allowed to be transmitted to the cable, the distance which we allow to running this cable to connect devices or connect devices to the network, and the protection of the cable itself. Some of them they don't have protection, some of them they have protection. So categories are numbers. So category number 3, number 4, number 5, 5E, 6, and etc. 7 and 8. To have these days, to have functional network, you should have at least the category 5E cable, which provides 100 megabits network. It's not shielded, but we don't need it, because for LAN network we're not using a shielded twisted pair cables. We are using unshielded twisted pair cables. So cable link and standard and connection. Here on the picture you can see the connectors itself. So here is the termination, how we terminate our cable, what connector we put to our cable, and this is RG45. RG45 socket, it looks like that on this picture, and you can see those sockets on the wall or on the routers, on the switches, or on the racks. And here how it use those connectors on the cable itself, how we connect it. So there is a proper termination of the connector and there is a not proper termination of the connector. On the top picture you have a not proper termination of the connection. So the cables should not be loose here. Here is the proper termination of the connection. Now, because we talk about it, by lining up those colors, you can create different type of cables. Here is the color schema. So you can create 2 types of cables. One is a straight through cable and another is a crossover cable. So here is the schema of those cable, or on their abbreviation, technical abbreviation is T568A and T568B. But what most important, and you're going to have in your exam, is the abbreviation of the cable itself, crossover or straight through. What does it mean, those cables? So crossover cable is connecting the same devices, which means computer to computer, switch to switch, router to router. Same group of devices are connecting by the crossover cable. Different type of devices are connecting with straight through, or somewhere you can find as a straightforward cable. As well, there is another cable which called rollover cable, is a proprietary of Cisco cable. Those cables are used only for connecting computer into a Cisco router or Cisco switch. The console cable, they call it a console cable. Now, the latest one, which we are using these days, is the fiber optics. Properties of the fiber optics, not as common as UDP, because of the expense involved. So it means the fiber optic is very expensive, and it's used rarely and only in certain occasions. Ideal for some networking scenarios, transmit the data over longer distance. Here is the point. So we can use the fiber optic to transmit our data in wide area network where there is a lot of distances between the devices. Less susceptible to attenuation and completely immune for EMI or RFI. Why? Because the fiber optic carrier of the data is light impulse. It's not affected by MRI or RFI. Made of flexible, extremely thin strands of very pure glass. Use a laser or LED to encode the bits as pulse of light. So one of them are more cheaper than others. That's why one fiber optic has a little bit much worse characteristic than other fiber optics. We're going to talk a little bit later about it. But that's why they use two types of source of light pulse. It's LED or laser. Now, two types of fiber. Single mode fiber and multi-mode fiber. And they're using different types of light pulse source. So, single mode fiber, here on the picture, very small core, use expensive lasers. So, here we are using this cable in the large instances where the signal must be delivered with the same quality, long distance applications. In the multi-mode fiber, we are using a bigger core and we can use a much cheaper light sources like LEDs. And as you can see here, we have the limitation of the speed and distance. For the left side, the single mode fiber, we almost don't have a limitation. There is limitation, but it's a very large amount of kilometers you can provide by single mode fiber optics. So, fiber optics cabling now is used by four types of industry: enterprise network, fiber to the home, long haul networks, and submarine cable networks. Fiber optic connectors, you know the cable, you have to connect that cable to the device, and there is a few connectors to be terminated with the fiber optic. So it's a straight tip ST connector, loosened connector LC, and subscriber connector SC or duplex multimode LC connector. Depends on the type of device, you're using different type of connectors. Fiber patch cord is look exactly like that. So you have a SC, MM patch cord, LC, SM patch cord, STLC. So you see here in this cable, you have two different types of connectors, two different type patch cord, or you have here ST to SC patch cord connectors. Bandwidth. UTP cabling, supporting 10 megabits to 10 gigabits. Fiber optic, 10 megabits to 100 gigabits. You see, it's 10 times more than UTP. Distance. So LAN is formed by UTP because the distance inside the building, inside the room, inside the floor, it's limited, it's not too long. So relatively short, it's from 1 to 100 meters. Comparing with the fiber optic is up to 100,000 meters, guys, 100,000 meters. Immune to EMI and RFI. It's low by UTP cabling and is high to fiber optics. Fiber optics is not affected by those distortions. Immune to electrical hazard. Again, the fiber optic is high immune to this electrical hazard, and only because the source of the carrier of the data is light pulse. Media connection costs the lowest, but the fiber optic cables are very high cost. They have a very high cost. Wireless media. Properties of the wireless media, as you know, is the coverage and speed. So coverage and speed. Coverage is the effective coverage can be significantly impacted by the physical characteristic of the deployment location, which means if you have a wireless, it's always, you must know where you're providing that wireless. Is there any building surrounded, or the concrete is basically absorbing the radio waves and they are lowering the signal and degrading the signal. Types of media. For the types of wireless media, so we have a standards of wireless media, and this standards is called 802.11. Of course, the different variation of these standards, we know it as Wi-Fi A, B, G, N, AC, AX, or the latest abbreviation is a Wi-Fi 5, Wi-Fi 6. Okay, wireless access point is very important to know. It's concentrate wireless signals from user and connect to the existing copper-based network infrastructure. So somewhere in the building, to have a wireless access, you're placing an access point. Whenever user it connects to that access point, the access point is connected to the current wired copper cable network. That's it for this subject. We'll see shortly to start another one. Thank you. Duplex and speed testing. We're going to talk about some issue that might occur in the cables and switches during the communication. We talk about half duplex and full duplex, and as you already know, and I mentioned it before, half duplex is when one computer sends and another computer waits to receive. Okay? So it cannot be simultaneous transmission, sending and receiving. Full duplex, from the other hand, is the opposite. So, two of the most basic settings, and this is applied to every network card, to every network port. We have a port on the switches, we have a port on the routers, and we have a network ports on our computers, which are network interface cards, right? RJ45 ports. So those ports, they are working on full duplex and half duplex. So, two of the most basic settings on the switch are the bandwidth, or we call it speed, because it depends how long, how big is the bandwidth, and how big is the information we can put through for the certain time of period is the bandwidth, but that's how we measure actually our speed. And duplex settings for each individual switch port. On the switch we have ports, which are networking ports, and those ports, any switch can have a maximum 48 ports. It is critical that duplex and bandwidth settings match between the switch port and connecting devices. So computers are connected to the switches and devices connected are to the switches in order to form a LAN. So port on the switch and port on the computer, they must use the same communication channels. For example, two channels or two types of duplexing, full duplex and half duplex, and both devices must have used the same. If switch is using full duplex, then end device must use also a full duplex. If switch is using half duplex, then end device is using a half duplex. This is just an example. Switches are working on full duplex. But to have a negotiation communication, both must use the same duplexing. So that's why the networks, they are having the auto negotiation. Is an optional function found in most Ethernet switches and NICs. NICs is a network interface card. It enables two devices to automatically negotiate the best speed and duplex capabilities. Okay. Duplex and speed settings. So duplex mismatch is one of the most common causes of performance issue on 100 megabits. 100 megabits, it means your network card is allowing to accept 10 up to 100 megabits speed of the bandwidth. It occurs when one port on the link operates at half duplex, while the other port on the link, it operates in the full duplex. That's what I just mentioned before. We should not allow that. Both ports must have the same duplexing. This can occur when one or both ports on the link are reset and they are returning back into default stage. If for one network adapter the default stage is the half duplex, then after the reset it's going to turn back into the half duplex. So before you start using the communication channel between both devices, you must ensure that they are using the same duplexing site. And the auto-negotiation process does not result in both link partners having the same configuration. So you just need to do it manually. It also can occur when the user reconfigure one side of the link and forget to reconfigure the another side of the link. So basically, everything what you have to do is to check that both sides are they using the same duplexing. If it's full duplex, both sides must use the full duplex. If it's half, both sides must use the half duplex. And sometimes after resetting the sites, you should not rely on auto negotiation, because sometimes auto negotiation won't work. So best practice is to configure both Ethernet switch port as full duplex. So you are configuring all switch port at full duplex, and your network card is configured as full duplex, and it will avoid a mismatch. This we finish with this subject, and we will start very shortly with another one. Bear with me, we're gonna see each other shortly. Hello everyone, again. So topic will be comparing TCP and UDP protocols. And this is continue our journey to successful end, taking the exam of CCNA. So, transport layer. That's the layer where the stands are those two protocols, TCP and UDP. Roles of transport layer. It is fourth layer of the OSI model and third layer on the TCP IP model. Here we are talking and we are having TCP IP model, and transport protocol is the third layer. Is above the internet layer and beneath the application layer. All layers, as you know from the CCNA curriculum, they are communicating between each other, and the things which are happening on those layers is exactly affected the transmission of the data. So transport layer is responsible for the logical communication between application itself. For example, Facebook with Facebook, Viber with Viber, WhatsApp with WhatsApp. WhatsApp cannot communicate with Viber with the same communication channel. That's why they have a different communication channels. The link between application layer and the lower layer that are responsible for the network transmission. Transport layer responsibilities, which is very important to know when you start preparing yourself for the exam. The transport layer has the following responsibility: tracking individual conversation, which means the transport layer has reliable function of tracking each conversation. It's opening a session and tracking each conversation, segmenting the data and reassembling the segment. From OSI model experience, you know that at the transport layer it starts a process. It's called segmenting. Why this segmentation starts? Because imagine we have a different data. One data is very big, very long. The another data is very short. There's a very big conversation and very short letter. And all those data, they are carrying in different way, because bigger data is going to be much slower than a smaller data will be much faster. To prevent these differences from transmitting the data over the network, the OSI model at the transport layer is start process called segmentation. So it means it's dividing a data into a smaller equal of size pieces, and each piece it has been added a sequence number, so it's called sequencing. Also, the piece and every header every layer add its own header with its own information. So transport layer add a header with its own information, internet layer add header with its own information, data link add a header with its own information, and etc. So basically every header uses the segmentation and multiplexing to enable different communication conversation to be interleaved on the same network. The transport protocol layer is this one, and again is the third one from the TCP/IP model. What protocols we have in there? At the transport layer we have two protocols which are carry this transportation. It's a TCP and UDP protocol, transmission control protocol, and user datagram protocol. As you can see here on the picture, the above layer also has a protocol and the bottom layer has also protocol, which means that every single layer of the TCP/IP model or the OSI model, they have their own meaning to work and they have their own protocols. At the application layer we have, as for the example in the picture, is FTP, HTTP, SMTP, DNS, FTP, and many others. Sorry. So what does it mean that? It means that application layer is exactly connected to the application itself and their protocols which makes the application work. For example, HTTP or web browsing, it's handled by HTTP protocol, application protocol. File transferring is handled by file transfer protocol, application protocol. SMTP protocol is handling a sending emails, and this is also an application protocol. DNS, domain name system, which is resolving names, vice versa, IP addresses, is handled by DNS protocol, and etc. Usually, the protocols, the application protocols are well known, and there is around 1024 well-known port numbers and their assigned protocols. Here, the bottom layer, transport protocol, has TCP and UDP. Let's talk about those two protocols and compare them. Transmission Control Protocol. Transmission Control Protocol provides reliability in flow control. It's very important here to see that this is the major difference between those two protocols, and each of them is using in different way and by different services. The major function of the TCP is to provide reliability and flow control. TCP basic operations is number and track data segment transmitted to a specific host from a specific application. Specific host from a specific application, track, which means Facebook to Facebook, WhatsApp to WhatsApp, specific application to a specific application. It's tracking that it must be negotiated between them to use the same application to establish a channel of communication. Acknowledge received data. What it means that whenever you send something, the TCP ensures the data will be delivered at the destination point. If it's not, that the TCP will ask the sender to send again the missing data or the missing piece of the data. Because, as you know, and remember from the 5 minutes ago, we talked that at the transport layer there is another process which starts called segmentation. Segmentation is dividing the data in small equal parts. Continuing, retransmit any acknowledged data after a certain amount of time. That's exactly what I said. When the destination provides the acknowledgement to the source, hey, certain data with the sequence number this and this is missing, please send me again. Then the source is obliged to send it again, these numbers, these sequence numbers. Sequencing data that might arrive in a wrong corner. That means that whatever data has been sent through the media and goes across the globe in a different ways, it will arrive in a different order at the destination point. But this doesn't mean it will not be reassembled. The TCP/IP, the TCP protocol, it will reassemble the data in the correct order how it's sent. So send the data at an efficient rate that's acceptable by a receiver. We talk about that, about the full duplex and half duplex. There must be auto-negotiation in order to establish the communication channel. User datagram, another important protocol in the transport layer, is their UDP, and it provides the basic function for delivering datagrams between the appropriate application, and here look carefully, with very little overhead and data checking. Very little overhead and data checking, which basically means there is no reliability. This protocol is not reliable. There is no acknowledgement. There is no checking. Is the right order the user datagrams arrive, or is not the right order they arrive at the destination point, or there is maybe some sequencing number is missing? No. That means no reliability. So UDP is called connectionless protocol. TCP is called connection oriented. So UDP is known as a best effort. Why? Because it's very fast protocol. Very fast. Why? Because there is no acknowledgement process. There is no double checking process to check if the sequencing number of the certain pieces arrive at the destination point or not. And then the destination point, if there is some missing part, will ask the source to re-establish, so resend the data. UDP doesn't have this. That's why this missing part, it makes this protocol much faster. What are the services that are using this protocol? We'll see right away. So UDP, because it's a faster protocol, low overhead, does not require acknowledgement, does not resend the lost data, delivers the data as it arrives without reassembling. And this is the protocol which is called best effort. The services that are using this protocol is gaming, video calling, so like streaming services. They don't need acknowledgement. If the data has been sent, that's it. If it's arrived, arrived. If it's not, that's it. That's why these services, they don't need acknowledgement. Also Skype communication, call communication. I'm not talking about texting. I'm only talking about the voice communication. Skype, Viber, WhatsApp, Facebook, Messenger, but only voice communication. The TCP, from the other hand, is reliable, acknowledge the data. It means it checks if the old data arrived, then resends the lost data, delivers data in sequence order, and the reliable services are web browsing, emails. For example, web browsing. Have you ever seized whenever you type on the browser google.com and you receive just the 25% of the Google page? Never. Either you receive the full page of google.com, either you receive nothing and you receive error. The page cannot be displayed. That means you're receiving something, but not just a partial. The same for email. You're sending email to the destination. The destination receives just 25% of the email, but not the entire email. It's not possible. Either entire email, either nothing. Error message. That's how we know that data is well provided. So TCP Overview. TCP Features. Establish a session. TCP is connection-oriented protocol that negotiates and establishes a permanent connection, or we call it also session, between source and destination devices prior to forwarding any traffic. So whenever application opens the channels, it's establish the session TCP and keep established until the destination don't receive all information from the source. When the destination acknowledges that whole data arrived, then the session has been terminated. Next, ensure reliable delivery. For many reasons, it is possible for a segment to become corrupted or lost completely. Many reasons for that. Loose cable, cut cable, broken device, or something. So the packets can, the data can be corrupted or even completely scrapped as it's transmitted over the network. So TCP ensures that each segment that is sent by the source arrives at the destination. If those data has been scrapped or lost, the source will send it again. Provides the same order delivery. It means by the destination point, the TCP checks the sequencing order. If it's scrambled because they arrive in different time, the TCP reorder the sequence number and make them in correct order. Then the last one is supports flow control. Network hosts have limited resources When TCP is aware that these resources are overtaxed, it can request that sending application reduce the rate of data flow. So auto negotiation always must be the same. That's why TCP is keeping and looking for the best communication channel. And if it changes, it asks both sides to change their communication channels. Applications that use TCP. We already talked about web browsing, file transfer protocol, when you're sharing files with each other using file servers, SMTP, which is the protocol which is carried out for sending emails, SSH is secure shell if you want to connect to certain devices using secure telnet, and in this case is SSH. And these application protocols are using a TCP as a carrier, as a transportation. UDP. TCP we finish. Now it's time for UDP overview. UDP features. UDP features include the following. Data is reconstructed in the order that it's received, which means if it's received in the wrong order, that's how it's reconstructed. Any segments that are lost, they are not resent again. Because again, the UDP doesn't have acknowledgement and it's not reliable protocol. There is no session establishment. There is no session establishment at all. It's not like TCP, which establishes a session and keeps and tracks the application. And the sending is not informed about resource availability, which means the sender just sends the data without ensuring that the receiver is available to receive it. Applications that use UDP. Here in this section we know that applications are not reliable. And what are those applications? Are DHCP, DNS, SNMP protocols, TFTP protocols, voice over IP, video conferencing. All of these protocols are using UDP protocol as a transportation. Port numbers. It's very important that every communication channel has a port of communication. It's like a door. If you enter certain building, you have to open the door. Then if you want to exit, you have to exit through certain door. The computer communication is absolutely the same. So we're having outgoing port and incoming port. So let's take a look. In the communication, always there is two parties, destination and source. So destination port and source port. The socket pairs. The source and destination port are placed within a segment, and every time depends either you're sending or receiving communication, the port could be different. So here, the source and destination port are placed within a segment. The segments are then encapsulated within a packet. The combination of the source IP address and the source port number, or the destination IP address and destination port number, is known as a socket. Socket enable multiple processes running on the client to distinguish themselves from each other, and multiple connections server process to be distinguished from each other. But what most important? So continuing with the source port numbers and destination port numbers, there is a variance of number of those ports. Let's take a look. Port numbers group. Totally, we have around 65,000 ports. From those 65,000, around 1,024 ports are well-known ports and they are predefined, which means they are not changing. Each application has its own port for communication. Each application. What we have to do, because 1,024 is not possible to memorize it, we have to memorize it around 30-40 ports which are oftenly used. For example, port 20, 21, 22, 23, and etc. But what are the information behind those ports? Port 20 and 21, it's a file transfer protocol application which is transferring files. Port 22, it's a secure shell, SSH. Port 23, it's a telnet. Port 25 is a POP3, it's an incoming mail protocol. For port 53, it's a DNS, Domain Name Service. One more thing, some applications they're using both protocols, UDP and TCP. So DNS is one of those protocols who are using TCP and UDP protocols. 67, DHCP has 68 as well. 69, TFTP protocol. 80 is well known as web browsing port number. It's a HTTP. And 110, it's a POP3. And 143 is a IMAP protocol. As you can see, those protocols are already predefined. What you have to do is just memorize around 30-40. They are most used protocols ever. How to troubleshoot? We have various tools of troubleshooting and we have various commands. To troubleshoot, we use certain commands. One of these commands is called netstat. So netstat command is basically helping us to see what communication channels has been established in our computers. And how to do that? By using that command netstat. When you type netstat, it's going to give you the whole list of all establishing the port communication channels, along with the destination IP address, source IP address, the protocol type of communication, and port number. As you can see on the picture here below, we're having a protocol communication is a TCP, then followed by IP address of the source, followed by double column, and the port number, outgoing port number of communication, then followed by incoming or destination with incoming port number of application. So here at this record